Okay, for the video record and for those of you who came in class late, I put this problem on the board because it's hard, and it's sort of like the bonus problems will be on next Thursday's test, exam number 2. Okay, and I got people started by saying, okay, solving this, the first thing I saw was it was a proportion. You could stick a 1 underneath here and get one fraction equaling one fraction. And that means you can cross multiply, which is what I did. I multiplied this times this and this times this. Okay. But over here on the left, this was a radical times a radical. So I used the inside, inside, outside, outside rule to multiply the insides together. Go off to your scratch paper. This becomes 2x distributed into here becomes this. So we're down here. Now, this is a radical equation. To do a radical equation, the rule was isolate the radical, it is, and then power both sides. Well, in this case, it's a square root, so we're going to square power it. Okay, the square power automatically cancels the square root. So we have 6x squared minus 5x equals 25. 5 squared is 25. So now we're left with a power equation. Before it was a radical equation. We got rid of the radical, but now we have a power equation. So a power equation means I must make it equal 0, and then I attempt to factor it. So 6x squared minus 5x minus 25 equals 0, because I take 25 away from both sides. And now I factor it. Well, the AC on this is negative 150. 6 times 25, negative 25 is 150. So you start thinking, oh, geez, what times what is 150? I don't know. Okay, but you can break it down into 15 times 10, which is 3 times 5 times 2 times 5. Now, any way you put those together, 3 times 5 times 2 times 5, any way you rearrange it will eventually equal 150. So remember the AC method, I want to put these together in such a way that they multiply to make 150 negative, but they add or subtract to make negative 5. Okay, so I think if I did that, I'd go, well, right there, 15 times 10. So if I go negative 15 times 10, okay, that's my negative 150, and that's my negative 5 in the middle. So yeah, it was a little bit hard, but we use that to go 6x squared minus 15x plus 10x minus 25 equals 0. Remember, we haven't done this in quite a while. We have to group the first and the last. So what can we take out of there? We can take a 3x out of that group, leaving a 2x minus 5, plus I can take a 5 out of that group, leaving 2x minus 5. Ooh, still equals 0. Okay. So we got, I just turned on closed captioning, so if everything freezes, hang with me while I have to reboot. So I'm not quite done. We factor the 2x minus 5 in front. That's how we did we said that comes in front, so 3x plus 5 is in back. And then we separate it and solve the babies. 2x minus 5 equals 0, or 3x plus 5 equals 0. This gives me x is 5/2. This gives me x is -5/3. Okay, we are supposed to check. Okay, and I will be darned if I'm going to put those back here. It's not all that bad, but I just don't want to do it. I did check it on my calculator. It turns out they both do check. Okay, so our solution set here was 5/2 and -5/3. So anyway, I like that problem because it involved first seeing this as a proportion, which is cool. But in the middle of that, you had to remember how to multiply radicals. Then you had to solve a radical equation by powering both sides. And then you had to remember all that factoring stuff. So I like this problem because it brings in lots of skills. Any questions on that? Any step you don't like? Okay. I want to digress for just a moment. If we're at this problem, 6x squared minus 5x minus 25 equals 0. Okay, and we know we have to factor it. The AC method that I showed always works. This technique of getting the AC, of breaking the 5x into 15 and 10 and all that kind of stuff, that always works, but it's slow and it's a pain in the rear. So let me talk about just a little bit an alternate way to factor. And when you read books, they call it guess and check. And I'll show you why in just a moment. Okay, if you read the text that's associated with the homework on mom, if you go back to the factoring, whatever chapter it was, 7, and you go back and read, they talk about multiple ways to factor. And I've only taught one way, okay, because I didn't want to confuse the issue. But there are several ways that instructors teach. AC method, or some people call it the diamond method or the cross method or something, I don't know. That is that. But there's what I call the belly button method. Okay, the belly button method. We know that there are two types of belly buttons. There's innies and there's outies. And we know that the belly button is located more or less in the middle of your body. Now, I call it the belly button. Everybody else calls it guess and check. Let me show you how it works. And then if you like this and want to see more of it, I'll stick around after class, or we can do some tomorrow. You can ask me tomorrow in class, whatever, I'll help you learn it. It's much faster, okay? But it requires a lot of work. I know that a trinomial, if it factors into two binomials. Okay, so I just put the two binomials there. Now, in my mind, okay, how can I break up 6? Well, 3 times 2, 3x, 2x. I'm guessing, I'm just hoping. Okay, what times what makes 6? 3 times 2. And you break up an x here and x here. What times what makes 25? Well, 5 times 5. So you put a 5. Now, this is where the belly button comes in. Okay, your innies, okay, check this out. Your innies, which is a 10x, and your outies, which is a 15x, somehow have to add or subtract to make the middle. Okay, so you look at that and you go, the 15 has to be negative the 10 has to be positive. So the 15 comes from here. I slap a negative on it. Just put it there. The 10x comes from here. So I put a plus there. And that is the same answer that we got when we did this. It equals 0. But the vast majority of my factoring of my work was done in my head. And it was, guessing. I just guessed. How do you break up 6? 3 times 2. How do you break up 25? 5 times 5. So I just put them here. And then I played with the belly button. The innies somehow and the outies have to make the middle, the belly button. Okay. Rule of thumb, if I can't belly button factor a problem within, let's say, 5 seconds, 5, 6, maybe 7 seconds, I go, forget it. I go back to the AC method. Okay. If it's an easy trinomial, okay, and by definition, what I called an easy trinomial, that was when you had x squared minus x minus 12 equals 0. That was when your coefficient was a 1. Then the belly button method always works, okay, without too much struggling, okay? Remember, and I termed it easy trinomial. No book in the world calls it that. I do. If it's an easy trinomial with the coefficient of the x squared being a 1, then you can just go boom, 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 boom. X squared breaks up as x and x. What do I do to make 12? 4 times 3. Okay. Now play with your belly button. That's wrong. Middle is 3x. Innies are 3x. Outies are 4x. But I have to make -1. So the 4 has to be negative. The 3 has to be positive. So that tells you where you put your signs. And that's the factoring, and then you can go from there. Now, not that you have a lot of time. I know several of you are busy with other classes, with jobs, with work, whatever. But you might want to go back to chapter 7, 6, and 7, okay? And pick trinomials and try this belly button method as a faster way to factor. Now, if you're happy with the AC method in grouping, like this one, and don't want to learn anything new, you're okay. Don't worry about it. It's just not that big a deal. But a lot of time on tests, speed is kind of your ability to finish problems quickly in a given amount of time is important. So this belly button method helps you to get through a problem a whole lot faster than the AC method does. Okay. Questions about my belly button? None? Okay. I encourage you to go back and find some trinomials and just try it. Again, if you can't do it within 5 to 7 seconds, if you fiddling around here, you go, I can't get it. Forget it. Go back to the AC method. AC method is slow, but it always works. All right. I need to erase the board. Is anybody going to yell at me? All right. All right. Quick review. Yesterday, and the day before, actually, I introduced what was called the complex numbers yesterday, I guess. Complex numbers. Okay. And they were written as A plus or minus BI, where A is part of the real numbers and B is an imaginary number. The real numbers are what we've always worked with. The real numbers are all the numbers that we've always used on the number line. The imaginary numbers come from the, if you wish, rule or definition that says the square root of -1 is worth something called I. That's the rule that mathematicians use to define an imaginary number. If you're doing the square root of a negative, it's an imaginary number. Okay. However, 99 times out of 100, that may be the rule, but what I said yesterday is we use the fact that -1 is worth I to the second power. How do we get that rule? By squaring both sides. From this rule, if you square both sides, you'll get this rule. Okay, and this is more useful to us. All right. The other thing I said, very, very important for the imaginaries, the instant you see a negative inside of a square root, you take it out and write it as I. So for example, if you have the square root of -4, the first thing you do is write it as I times the square root of 4. That's the first thing you do. So the square root of -4, you go, aha, negative inside of a square root. Okay, we take the negative out, call it I, and then we worry about the square root of 4. Well, the square root of 4 is 2. So this is I times 2. And then right at the end of class yesterday, I said it is, we always write the imaginary number as 2I. We put the I in the back of the number unless it was a radical. I'll show you that in a minute. Well, I'll actually show it to you now. Do I have room? Yeah. Okay. So, example, if I have the square root of -18, the first thing I do is take the I out, and I have I times the square root of regular 18. So the negative inside the radical comes out and we call it I. But remember, all this stuff only works for square roots, not cube roots, not fourth roots, just square roots. Okay, if we simplify the square root of 18, okay, square root of 18 is 9 times 2. So we can take the 9 out as a 3. So this becomes I times 3 times the square root of 2. Now, we kind of cheat. I said earlier that we always put I at the back end of a number, 2I. Unless it's a radical number, in which case we kind of put I in front of the radical, 3I radical 2. Okay. But in all cases, the first thing we did was take the negative out of the square root and call it an I. Then worry about the rest of the problem. All right. That was a real quickie review of complex and imaginary numbers. And I know for some of you, it's brand new. Others of you, I know you may have been introduced to it and then forgot everything about it. So anybody have any questions about what I've said up here or what I said yesterday. Okay, then just for quickie review, make sure everybody's got everything. I need to erase the board. I'm going to put up 5 problems, see how you do on it. Okay, so can I erase the board? Anybody have anything up here they want to keep or they want to ask a question about? Okay. Okay, so I started to do number 1 over here. I just rewrote it. Okay, first thing you do is take the I out. So you write 3i radical 12 and 5i radical 2. Now, there is some leeway as to how you actually then continue the rest of this problem, but I'm going to use the outside, outside, inside, inside rule for multiplication of radicals. That's what we're doing. Okay, you use outside times outside, so that gives us 15i to the second, 3 times 5, I times I, square root of 24. Inside, inside. Okay, now we've got to simplify this. If you have the calculator that does simplifying, great. Okay, if you don't, the square root of 24 is 4 times 6. You can take the 4 out. But when the 4 comes out, it comes out as a 2. So we have 15 times the -1, because I squared is worth -1. Okay, 24 became 2 radical 6. The 4 comes out, square root of 4 is a 2, the 6 stays inside. Put all this together, you have -30 radical 6. You might have used slightly different steps, but that's the answer to number 1. Yes or no? Anybody? Is that okay? All right. Number 2 is much more straightforward. 6 times 2 minus 3i minus 3 times 4 minus 7i. Okay, so you guys would probably distribute, which is what that's asking you to do. 6 times that, so 12 minus 18i minus 12 plus 21i. Add like terms, the two 12s, positive 12, -12, are the real numbers. So in our minds, those are like terms. 12 and 12, they wipe out. But -18, positive 21 is plus 3i, or just plain old 3i. Is that okay with everybody? Okay. Now, before I go on, I need you guys to wake up. Okay. Don't turn. Is the ball game on tonight? Have they started yet? Yeah, they probably have. Okay. Pay attention to me for just a second. Mom, when she's questioning you regarding complex numbers, will give a problem like this and will say, what's the real part and what's the imaginary part? Well, that screws up people. The real part is 0, because there's an implied 0 in the real numbers. Remember, a complex number is a plus or minus bi, where a is the real number. Okay, so in this case, even though we know that the 12 and the -12 cancel each other, okay, it's still, the real part is still 0. And the imaginary part is just the 3. the I is assumed to be, yeah, dummy, that's why it's imaginary. It's got an I on there. So, but most people will figure out the 3 thing, but this 0 here, it's just a weird thing in mom. She's correct. Okay, the real part is 0, even though we left it off. Okay, so be careful. Mom's gonna try and trip you up. And you guys are gonna come back in a couple of days and yell and scream at me, and that's okay. We'll go over it again. All right, so that's 1 and 2. Number 3, we had 6i times 5 plus 2i. This is straight distribute. So this is 30i plus 12i squared. Seems pretty simple. Okay. This is 30i plus 12 times -1. Remember, again, always simplify I to the second power as -1. This is -12 plus 30i. Remember, again, to write a complex number, the real part has to be first. So even though your math has the 12 in the back, the -12 in the back side of the right side of the problem, complex numbers require that the first number is the real part, the second number is the imaginary part. So you did have to switch these together, or switch these around, I'm sorry. That okay with everybody? Okay. So then we have number 4, which is 3 plus 4i times 3 minus 4i. Okay, what is this? 2 plus 5i squared. Okay, just don't want to forget it. Okay, so they're asking us to multiply this. Again, whether you FOIL it or whether you build the box, that's your business. I don't care. 3, 4i, 3, -4i. So we multiply. 3 times 3 is 9. 3 times -4 is -12i. 4i times 3 is +12i. And 4i times -4i is -16i squared. But that makes -16 times -1. -16i squared is -16 times -1. So what we have here is 9 plus 16. So the final answer for this problem is 25. Okay, this was a +16. Okay, notice what happens every single time we use conjugates when we were simplifying radical binomials. Okay, I'm going to go over that in a minute anyway. The junk in the middle, when we multiply the conjugates together, it seems like the stuff in the middle here always cancels each other out. And that's the truth, it does. So is that okay with problem number 4? Multiplying these two conjugate pairs together. No questions, huh? I just did such a hell of a bang up job last night that you guys are just getting these all perfect. I must be wonderful. Okay, let's see what happens. I must be conceited, but that's another story. 2 plus 5i quantity squared. Build a matrix. Again, if you use FOIL or another system to multiply these, that's okay. I don't care. So we have 2, 5i, 2, 5i. So when I multiply 2 times 2 is 4. 2 times 5i is 10i. 5i times 2 is another 10i. 5i times 5i is 25i squared. But that makes 25 times -1, which is -25. So where am I on the screen? Okay, so I have 4 plus 20i, because 10i and 10i make 20i, minus 25. So final answer for this problem is -21 plus 20i. -21 is the real. 4 and the -25 is how I got -21. And 10i was 20i. Okay. And pretty much that's it for review. I want to get into some more complex number stuff, but you kind of have to, I need to make sure that you're pretty comfortable with the stuff that we just did. So any questions about any one of these problems that we did? Okay, then hang on one second. Okay, if you go back and look through the problems that I just stupidly erased, we've basically talked about how to add, subtract, and multiply either complex numbers or imaginary numbers. What we've been avoiding is division, okay, until now. So right now, this is still all part of that chapter 9.0, complex numbers. It's all part of that first section, okay? Up to now, we've done add, subtract, multiply of either complex or imaginary numbers. They kind of all lump together somehow. All right. If we had 2 over 3 times the square root of 5, okay, what's wrong with that problem? What will I not accept on quiz number 2? You can't have a radical in the denominator. Now, I know it's hard to see you guys, okay, whatever, and you don't know whether you're supposed to talk to me or not, but okay, you can have a 3 in the denominator. 3 is cool, fine, have a 3, but you can't have that square root. So we spent a lot of time talking about how to rationalize the denominator by multiplying top and bottom by the square root of 5. Okay, well, consider, what if I had 2 over 3i? What's wrong with that denominator? We don't want I in the denominator. That's the rule. So get that somewhere in your notes. We don't want I in the denominator. Well, compare these two fractions. When the denominator was a monomial, I used the square root of 5, a monomial, to fix it. I'm going to do the same thing here. I'm going to multiply top and bottom by I. Just like here, I multiply top and bottom by radical 5, and I multiply top and bottom by I. Over here, this gives me 2i over 3 times I squared. But we know that I squared is -1. So this becomes 2i over -3. And that's your final answer. Okay. The basic fundamental rule for complex or imaginary numbers is you can't have I in the denominator. So in my mind, I see these two problems as very, very similar. You want to get rid of the square root of 5, so you multiply top and bottom by the square root of 5. Okay, and it works out whatever this one is. This was 2 radical 5 over 3 radical 25, but this is 2 radical 5 over 15. Okay, whatever, and whatever steps you took or didn't take, whatever. So when you had a monomial, mono meaning one thing, radical 5 that you want to get rid of, you multiply top and bottom by radical 5. If you have one I that you want to get rid of, then you multiply top and bottom by I. That's all. Can't have I in the denominator. All right, let's go back to this problem. What if we had 5 over 3 plus the square root of 2? 5 over 3 plus the square root of 2. This is a definite quiz number 2 question. This is a definite exam number 2 question. Can you simplify this? All right. The difference is this is a binomial. There's two things here. So there's a special game we used, okay, called multiply by the conjugate. So out of thin air, you pull 3 plus, sorry, dummy, 3 minus the square root of 2 to top and bottom. If the problem gave you 3 plus the square root of 2, you multiply top and bottom by 3 minus the square root of 2. Okay, and then you go off to your scratch paper to do all the work. So you have 15 minus 5 radical 2. On bottom, you're going to have 9 minus 3 radical 2 plus 3 radical 2 minus radical 4. Okay, if you use the box, I'm trying to avoid that right now. Okay, so when you use the matrix thingy, which you can go back and do on your own, you're going to get these things. The junk in the middle, the 3 radical 2's, will cancel each other out because one's a plus, one's a minus. Square root of 4 is 2, so you get 9 minus 2 is 7. So your final answer here is 15 minus 5 radical 2, all divided by 7. Now that's a quick review for rationalizing, that's what we called it, rationalizing a binomial denominator. You multiply top and bottom by the conjugate of the denominator. And whatever happens on top happens. But the bottom, if life is good, should turn into a single pretty number. Okay, well, what's that got to do with complex numbers? Well, here we go. What if I had 5 over 3 plus 7i? The rule is you can't have I in the denominator. Okay, but the denominator is a binomial, so we have to use the magic conjugate. 3 minus 7i, the top and bottom. So over here, I am going to do my box this time, my matrix, because I have 3 and plus 7i and 3 and minus 7i. I feel that you guys can distribute the 5 times 3 minus 7i in your head. Okay. The numerator is going to be 15 minus 35i. That's the top. But the bottom, you have to multiply together. Okay. Somehow the conjugate will use the box and see what we get. So 3 times 3 is 9. 3 times negative 7 is negative 21i. Positive 7 times 3 is positive 21i. And 7 times negative 7 is negative 49i to the second. But this is negative 49 times negative 1, because I to the second is negative 1. So this is positive 49. So I have 9 and 49 is 58. There's my answer. Okay. So again, in my mind, which maybe isn't fair or probably isn't fair, in some ways, imaginary or complex denominators like this act just like binomial denominators with radicals. You multiply by the conjugate and something magical happens. Okay. Monomial denominator, you multiply top and bottom by radical 5. Monomial imaginary, you multiply top and bottom by I. Is that okay? Okay, I want to have you guys do 2 problems just to practice this. And then we'll leave this complex number stuff and actually get into some brand new junk tonight. Okay, so I need to erase the board. I hope you got this on your notes because my problems are going to be very similar to this. We okay? All right, here we go. Okay, number 1, 5 over 7i. Number 2, 5 over the square root of negative 8. Number 3, 6 over 2 minus 5i. And number 4, 2 over square root of 12. No, wrong. Five plus the square root of negative 12. Sorry. So let's pause. And okay, so first problem. The only thing wrong with it is you can't have an I, and there's a single I down there. You can't have an I in the denominator, so we multiply top and bottom by I. Okay, that gives me 5i on top, 7i to the second on bottom, but I to the second is negative 1. So this is 5i over negative 7. Again, we've talked before where you can slide that negative if you want to put the negative on top, bottom, out in front, but that's the correct answer. Is that okay with everybody? There might have been another way to do this, but that's the final answer. Eventually, you had to multiply top and bottom by I. Any questions? None? All right. Moving to number 2, we have 5 over the square root of -8. So the first thing we do, the first thing is you have to take the I out of the square root. So you have 5I times the square root of 8. That's the first thing. Okay. Now, again, there's some argument as to what we should do next. There's multiple ways, but I'm going to simplify the square root of 8. So we've done that a bunch of times. So the square root of 8, I'm going to write it here, becomes 2 radical 2. Again, many of you have a calculator who will do that, but we've done that about 4 zillion times. So this becomes 5 over 2I radical 2. Okay, now we're not done. We're not done. In this problem, down here, this problem, there are 2 things that are wrong with it. You can't have a radical in the denominator, and you can't have an I in the denominator. So we're going to multiply top and bottom by I radical 2. Those are the 2 things that are screwed up. So those I radical 2 is what's going to fix it. So if we do that, this becomes 5I radical 2 on top. Okay. On bottom, we have 2 times I squared. I times I is I squared times the square root of 4. We use the outside, outside, inside, inside rule. Okay. 2 times I times I. Those are all on the outside. 2I squared. Square root of 2 times square root of 2 is square root of 4. But we know several things. Square root of 4 is worth 2. I squared is worth -1. So for a final answer, we have 5I radical 2 on top. On bottom, we have 2 times -1 times 2, -4. And we're done. That is the answer for problem number 2. Now, there was, based upon discussions that we've had, several students have asked before, I can see people trying a different way. Okay, that's fine, but this is the answer. So just make sure your answer matches my answer. Okay, again, I did it this way on purpose because there's 2 things I wanted to get rid of. I had to clean up the I in the denominator, and I had to clean up the radical in the denominator. So I had to use both of those math skills at one time. Is that all right with everybody? Any questions, any hesitation? Okay. These are like problems you're going to see in mom's homework when you get to chapter 9. So make sure you're taking good notes. Okay. Then number 3, 6 over 2 minus 5I. This is a binomial denominator, so we're going to multiply by the conjugate to plus 5I to top and bottom. So on top, we end up with 12 plus 30I, because we just distribute 6 into here. On bottom, we have 4 minus 25i squared. Shoot. All right, I don't want to skip that step. I shouldn't skip that step. Okay. On first question to everybody, are you okay with how I magically pulled the 2 plus 5i out of thin air, where I got the conjugate from? Is that okay with everybody? Okay.
Can you explain it one more time?
Okay. When you want to get rid of a binomial, 2 things. If this is 2 minus 5i, then you multiply by 2 plus 5i. Okay, these two are exactly the same, except one's a plus and one's a minus. Over here, because this is 5 plus radical 12, I'm going to sort of multiply by 5 minus radical 12. That's what's called the conjugate. Is that okay or not?
Yes, I got it. Thank you.
Okay. So I distributed the 6 into here. Now I got to go off to my scratch paper. And I'm going to erase this in a minute. So I have 2 minus 5i and 2 plus 5i. That's what I'm trying to multiply these two together here. So I have 2 times 2 is 4. 2 times 5 is 10i. Negative 5 times 2 is negative 10i. And negative 5 times positive 5 is negative 25i to the second. Negative 5 times 5 is negative 25. I times I is I squared. But this is negative 25 times negative 1. So this is positive 25. So my like terms, the i's here, they cancel each other out because one was a positive, one was a negative. And I'm left with 4 and 25, which is 29. Okay, and that's my final answer. But you do have to be able to recognize when you're trying to get rid of a binomial denominator. Binomial. 2 things, pluses and minuses between. You multiply by its conjugate. Its conjugate is the same numbers, except one has a plus in the middle and one has a minus in the middle. I need to erase my little chart here. Are we okay with number 3 now? I've done number 3. I've shown you my work. I'm going to erase it to make room. Are we okay? Anybody? Okay. Last one, number 4. Okay, again, there is more than one way that this could be attacked. I'm writing it again to make room. Okay, there is more than one way that this could be done. There's only one right answer, but there's multiple little steps. But all of them start with the idea that you have to take the I out of the square root. The negative inside of a square root comes out and is now an I. Okay. I'm going to be lazy. I'm not even going to bother to clean up that square root of 12. Because remember, our rules for radicals, they only have to be simplified in the final answer. In the final answer, they don't have to be simplified in the middle of the problem. Sometimes it helps you. Sometimes it's good to simplify the square root of 8 in the middle of the problem. But it doesn't matter. Eventually you have to. So here, I'm going to multiply by the conjugate. In this case, the conjugate is going to be 5 minus I radical 12 to top and bottom. Okay. So this is going to get messy. On top, I have 10 minus 2I radical 12. And I'm eventually going to have to clean up the square root of 12, but I'll worry about that in a moment. On bottom, I have to multiply these two together. So I have to go back to my matrix, my box. So here I go. Ugly. Boom, boom, boom. 5 and I radical 12. 5 and minus I radical 12. So 5 in the I radical 12 here, 5 in the minus I radical 12. Here I go. 5 times 5, 25. 5 times that mess is minus 5I radical 12. Okay. I radical 12 times that is plus 5I radical 12. And multiplying these two is negative, because positive times negative is negative, I squared. I times I was I squared, radical 144. 12 times 12 is 144. So this is negative times negative 1, because I squared is negative 1, times 12. Okay, negative times negative is 12. Okay, so final answer here, negative times 12 is 12. That's my answer. So what happened here? Okay, these are opposites of each other. They'll cancel each other out. What am I left with? 25 and 12, which makes 37. Okay, now I'm almost done. Got one little tiny thing to do, but I want to make sure I got everybody with me. Do you understand how I pulled the conjugate out of thin air again? This was 5 plus this mess, so I multiplied it by 5 minus the same mess. Okay, came over here to do my ugly multiplication. Okay, the only thing left for me to do is simplify the square root of 12. So anybody have any questions to this point? Okay. So if I look at negative 2I radical 12, just that part of it for just a second. This is negative 2I, and this is 2 radical 3. Again, go off your scratch paper, work out the square root of 12, which is 2 radical 3. Put that back together. This is negative 4I times the square root of 3. So this mess became this mess. Final answer, 10 minus 4I radical 3, all divided by the 37. So this mess here, I knew the square root of 12 had to be simplified somehow. So I came up to my scratch paper, worked it out, and then brought it back here into my answer. What time is it? 57. Okay, let's take about a 5-minute break, maybe a little bit longer. I gotta get something for my throat, but a 5-minute break, we'll come back and then we'll actually start something new. We'll drop these imaginary stuff for a while. So let's pause, take a break. For the next couple of sections, I'm going to use really, really bad teaching methodology. And that is, I'm not going to try and explain where the rules came from. Okay, I'm just going to use the old shut up and do it this way because it works. Over the next several days, I'll try and explain where they came from. But right now, all I want you to do is be able to do the problem in this certain way. Then I'll explain how and why it works. So the first one, this is in section 9.1. It's called the square root property. And the key for this is all of your x's are inside a quantity squared. That's really important. This only works if all of your x's are somehow being squared. So I'm going to show you the steps. First, we're going to isolate the quantity squared. Second, we're going to square root both sides. And really important, put plus or minus on side opposite the x. I'll explain what that means in a moment, but that right there, putting that plus or minus on the side opposite the x is the whole key to this whole process. In fact, that's the key to this entire chapter. Okay, and so right now I'm just going to write it down, and then I'll show you how to do it. Third, we're going to solve two equations. And fourth, we're going to solution set all answers. So let's take an example and show you what I'm talking about. 5 plus 2 x minus 4 quantity squared equals, let's say 12. No, let's say 13. Make it 13. Sorry. I want this one to be nice and pretty for us. Okay. So here we go. First off, are all of my x's in this problem inside the quantity squared? Yes. So I can continue. If they weren't, if there was another x out here or something like that, then we have to do a whole new technique, a whole different technique. But because all of the x's are inside the quantity squared, we can use this technique. So we're going to do isolate the quantity squared. That means we're going to first get rid of the 5. So that gives us 2x minus 4 quantity squared equals 8. We're going to divide both sides by 2, because that, remember, when you write 2 parentheses, it means 2 times, so you got to divide. So now you get x minus 4 quantity squared equals 4. Okay, so that's all built into step number 1. Isolate the quantity squared. Step number 2, we're going to square root both sides. Why? Because to get rid of a square power, the only thing that gets rid of a square power is a square root. Okay, remember we had that formula. Well, in fact, we're using it quite a bit in chapter 8 intermediate. We have the nth root of x to the nth power is x. Okay, the nth power and the nth root always cancel each other out. So we're going to write here, we're going to say the square root of this side, the square root of this side. This is going to give me x plus, oops, not plus 4, minus 4, sorry, because the square root and the square power cancel. And according to what I just said, I have to put a plus or minus in the problem on the side opposite the x. And again, I'm just saying, just do it. I'll explain it either tomorrow night or next week. So square root both sides, the square root and the square power cancel, and the square root of 4 happens to be 2, but you must put the plus or minus on the side opposite the x. Okay? You can't remember and just go, oh, at the end of the problem, I remember there's supposed to be a plus or minus, and just shove it in there somewhere. No, no, no. It's got to be at this step. Now, the 2 equations that we have, and some people can do them simultaneously, some people need to write them down, are x minus 4 equals 2, or x minus 4 equals negative 2. Those are the 2 equations. X minus 4 equals positive 2, or x minus 4 equals negative 2. So you solve, add 4, so you get x equals 6. This one here, add 4, x equals 2, because you added 4. So solution set, 6 and, whoops, 2. And that's it. So there is a really nice, they're going to get worse than this, but there's a really nice example of the square root property. It says when you square root both sides, it does 2 things. First, the square root cancels the square power. And secondly, it introduces a plus or minus, which means we're going to get 2 answers to this problem. Okay, before I erase and do another problem, how are we doing? Good. Okay, here you go. This is still a reasonably nice example. Haven't gotten nasty yet. Okay. Negative 2, quantity 2x plus 3 squared equals negative 32. Okay, how about you guys take a minute to give it a try. Isolate the radical, that means divide both sides by negative 2. Square root both sides, Remember to put a plus or minus in, try and solve the problem. So I'll give you a couple of minutes to try that. Okay, so we're going to divide both sides by -2. So that gives us 2x plus 3 quantity squared equals 16. Okay, I've isolated, step one was isolate the quantity squared, get it by itself. Now we're going to square root both sides. Square root, square root. That does two things. First, it cancels the square power. Secondly, it gives us a plus or minus. And it happens that the square root of 16 is 4. Okay. At this point, we have two separate problems. We have 2x plus 3 equals 4, or 2x plus 3 equals -4. So take away 3, that's 2x is 1, x is a half, divide by 2. Over here, take away 3, 2x is -7, x is -7/2. Solution set, 1/2 and -7/2. I'll give you a second to catch up. Okay, so two really good problems. We're going to get a little bit nastier in a moment. Any questions about these? Can I erase at least the one on the right over here? No one's going to yell at me. Okay. So we're going to kick the difficulty level up just a little bit on this problem. A little bit tricky. 5 minus 2 parentheses x minus 1 squared equals 21. Yeah, that'll work fine. Okay. I'll give you a couple seconds to kind of play with it. So we take 5 away from both sides. Be careful, this leaves -2 times x minus 1 squared equals 16. A lot of students lose the negative in front of the 2 right there. Be careful. Divide both sides by -2. We get x minus 1 quantity squared equals -8. Okay. Before we studied complex numbers, we could have quit here. Because how can somebody squared, how can somebody times itself equal a negative? It can't. But now all of a sudden we studied complex and we studied imaginary numbers, so it can. We're going to square root both sides, just like the steps say, square root that side. That gives us x minus 1, because the square root and the square power cancel, equals plus or minus I times the square root of 8. Huh? when you square rooted both sides, you've got the square root of a negative number. That instantly comes out as an I. So plus or minus I times the square root of 8. Notice Aunt Sally, PIMDOS is kicking in. The I stays with the square root of 8. It's plus or minus that mess. All right, our two answers, or two problems, I should say, x minus 1 equals I, okay, times 2 radical 2, or x minus 1 equals negative I times 2 radical 2. Remember, the square root of 8, sooner or later, has to simplify. Okay. Now, this is where you guys got to put your thinking caps on. Okay. First thing I did up here is when I took the square root of 8, of negative 8, I took the I out. I still had to put the plus or minus on there. Okay. Then I split it up into two separate problems. Okay. At the same time, I knew that I had to simplify the square root of 8. So that's what I did. Now, technically, to solve, I have to add 1 to both sides. Because remember, solving means get x by itself. So this becomes x equals 1 that I added plus 2I radical 2. You can't add those. That's a real number. That's an imaginary number. You can't add them together. You had to move the 1 over. You had to add 1 to both sides because you need to get x alone. Okay, but you have to say, I can't go any further. That's my answer, because I know I can't add real numbers with imaginary numbers. All right, we come over here to this side. We add 1 here, add 1 here. Again, that's to get x by itself. But this time I have 1, and then I have minus 2I radical 2. Again, I have the real number 1 and the imaginary number, and you can't technically combine them. Okay, so those are my answers. Now, hold on one more time. Okay, it's going to get really weird. I would accept this 1 plus 2I radical 2, comma, that's one answer. 1 minus 2I radical 2. That's what we had. Okay, that's fine. Or you will sometimes see people write, let's see, do I have room? This 1 plus or minus 2I radical 2. Because they recognize that both of these answers start with a 1. And the second number is a 2I radical 2, but one of them's a plus, one of them's a minus. So the two answers are identical, except one answer is a plus, one answer is a minus. This answer and this answer are identical to each other. This is listing the two solutions separately. This is kind of trying to get sophisticated and fancy, lazy for mathematicians, combining them into one kind of nifty answer. All right, I just did so much work on that problem. There must be questions in there somewhere. There's so many little steps in there. I can't believe. Okay. Well, I'm going to leave that. We'll pick it up again tomorrow night. This is 9.1. I want to get into 9.2 and maybe if we're lucky, 9.3. We'll see. So I need to erase the board. I got this example here, this example here. This got, all of a sudden, it got really nasty because it had imaginaries and it had radicals in them. But the process was the same. It just used all your skills. Are you sure there's no questions about that example right there?
Hey, Professor, what if we not take out the square on the x minus 1 equaling what I call the minus a? We just open it up, just kind of like getting the x square, and
You can't do that until it equals 0. You're trying to think of factoring it, I think.
yes.
If you're going to use factoring, then it must equal 0.
But once we open it, then we put a negative a back to the left side.
Okay,
Yeah.
okay, I hear what you're saying, but it wouldn't factor. The fact that we got imaginaries and square roots means that, okay, let me show you guys what he's talking about. That's a good question, because you're looking here going, that's a whole hell of a lot of work and I don't want to do it. Isn't there an easier way? I know what you're thinking. It's okay.
Yeah.
Okay, look, he's at this idea. Okay, he's there. He's saying, what if we squared this out to become x squared minus 2x plus 1 equals -8? Square that mess out, make it equal 0, plus 9, because you add 8 to both sides, equals 0. And now try and factor it.
You can't factor that one.
And you can't factor it. You can't factor it. So what you're really asking, your question is really awesome. What we're suddenly seeing is there are problems, equations that can't be solved using factoring. So all of chapter 9 is an introduction to, okay, if we can't factor, how do we do it? What are some other techniques? And that's what I'm getting at. So this is another different technique if you can't factor.
Okay, I understand.
Okay.
Yes.
All right. But no, your question is great. Okay. Because it's what everybody else was thinking. They're all thinking exactly, oh crap, this is hard. This is ugly. This is nasty. Isn't there an easier way? And the answer is no, factoring fails. So that's the way we have to do it, almost. That question was great. Anybody else have any other questions? And they don't have to be that great. They can be silly. Like my next question, is anybody watching the ball game? Who's winning? Nobody? Huh, Dodgers and Braves. Okay. All right. One of the questions you should be asking yourself is, wait a minute, how often do I come across an equation that has all of my x's inside of a quantity squared? How often does that happen? Okay, and the answer is not very often. but we can force it to happen. And so that's what chapter 9.2 is about. It's called Complete the Square. Spelled wrong. Complete the Square. And there is easy and there is hard. And then there's insane. For the next several days, I'm going to focus on the easy. Okay. Okay. What we're trying to do with complete the square. Suppose I gave you a trinomial, ax squared plus bx plus c. We've talked about trinomials and the a, b, and c number. There is a way, a technique that we can turn this into all of my x's quantity squared. That's my ultimate goal. I'm going to give you a problem. Actually, I'm going to give you an equation. And I'm going to show you the method, okay, that's going to allow you to take this and turn it into a quantity square. That's where the phrase complete the square comes from. We're going to take this and be able to turn it into a quantity square. Okay. So here I go. Okay. All right. I'm just going to solve this problem. Here we go. X squared plus 6x plus 2 equals 0. Okay. Now, it does not factor. Because think of your AC. Your AC is 1 times 2, which is 2. There's no way you could break 2 down to make 6. So this doesn't factor. Okay, so watch what I'm going to do. First thing I do is in this process, this is a whole new process. We move the 2 to the other side. We just move it out of the way. Get rid of it. Move the 2 out. And now we're looking to put a magic number here and here. Okay, magic numbers. Yeah, that sounds like math. Okay, how do you find the magic number? You do half times this number 6, which is 3. But then you write 3 squared here and here. Okay, let's repeat what I did. I take half of that number, 6. Half of 6 is 3. But then I square it and I add it to both sides. I put a 3 squared here. I put a 3 squared here. Okay. Now here comes the super magic. That's the missing number. That's the magic number that's missing, 9. So you had to add 9 here and you have to add 9 here. But you got to go through this process to figure out the 9. All right. It turns out that if you if you do this half of 6 equals 3 bit, this side will automatically factor into x plus 3 quantity squared. That 3 and that 3 are the same. You don't even have to think. You don't have to do AC. You don't have to do anything. If you do half times 6 equals 3, add 3 squared to both sides, but factor this as x plus 3, okay, equals 7. Where'd the 7 come from? -2 plus 9. I'll do another problem in just a second, okay, because I want to finish this one. Now, if you look at this, all of our x's are inside of a quantity squared. All of the x's are inside this thing. So we're going to now square root both sides. I'm going to do it this way because it makes the problem a little bit neater. So this becomes x plus 3 because the square root cancels the square power, equals plus or minus. Got to remember that plus or minus again. When you're using the square root of both sides, use plus or minus, and this is just simply the square root of 7. Okay. Solve the two problems. X plus 3 equals the positive square root of 7, or x plus 3 equals negative square root of 7. Take away 3. Take away 3. Oops. And solution set it. So it would be -3 plus the square root of 7 and -3 minus the square root of 7. Those are my two answers. Or if you want to get fancy, it's -3 plus or minus the square root of 7. I'm going to do another, don't panic. Okay. So what did I do over here? Let's go back through it again. First thing I did is I decided it doesn't factor. So then this new technique says, since it doesn't factor, the rules of factoring, we throw it out. You move the 2 to the other side and you make room, that's what those 2 blank spaces are, for the magic number. What should have been there? And the reason we put it on both sides is because we got a fundamental idea in math. If you add something to one side of an equation, you've got to add the same thing to the other side. So how did I come up with a magic number? I take half of that number, the B number is what it's called, half of it. Half of 6 is 3. I do 2 things with that 3. First off, I add 3 squared to both sides. I also use that 3 to help me factor the left-hand side. If life is good and I haven't screwed up, the left-hand side will factor as x plus 3. That 3 is positive, x plus 3. That side will become 7. And now we're going back to what we just finished in 9.1, the square root property. Before you ask questions, let me just do a whole nother problem. X squared minus 12x plus 25 equals 0. Okay. So real quick, your AC is 25. There is no way that you can break down 25 to equal 12, negative 12. So that tells us right now it doesn't factor. So we're going, damn it, doesn't factor. Got to use this new thing. So first thing I do is I move the 25 to the other side. Okay, I leave room for the magic number. But remember, I have to add it to both sides. That's what the double blank is. How do I find the magic number? You take half times negative 12, okay, is negative 6. Now be careful, but you put negative 6 squared to both sides. You square the whole negative 6. So in essence, that's 36. Be real careful about your math. You square that number. Square negative 6 is positive 36. Okay. This quantity will factor without, you don't have to think, you don't have to do anything. It will automatically become x minus 6 quantity squared. The left-hand side will become x, and then that's a minus 6. X minus 6 quantity squared. The right-hand side, okay, use your calculator, but this is 36 and negative 25. I believe it's 11. Okay, so what this process called completing the square has done, it's taken this trinomial and allowed me to manipulate it so that it now looks like a quantity square. So now I can square root both sides. This becomes x, where's my, okay, minus 6 equals, must remember the plus or minus, square root of 11. I'm going to skip a couple steps, okay, because number one, class is going long, and number two, well, it's easier. If we add 6 to both sides, we get x equals 6 plus or minus the square root of 11, and that's my solution set, and I'm done. Okay, those are my two answers, x plus the square root of 11, and then x minus the square root of 11. So again, I come back. You couldn't factor it. You used the AC and said can't factor it. Damn it. So we move the 25 to the other side. We calculate the magic number. Half times negative 12 is negative 6. Square it and add it to both sides because you got to keep it balanced. This factors. This was 11. Square root both sides. Questions? We are going to do more of these tomorrow night. Relax.
What happens if you actually square the magic number? When you factor, would it still be the same answer?
What do you mean?
Like actually
The-
square the negative 6 to
Oh,
like.
that doesn't matter. That doesn't matter. I'm just lazy. If you wanted to write 36 here and 36 here, that's cool. That doesn't matter. But you have to square it. Okay. I just knew that it doesn't matter on this side, at least, that I put 36. It does matter on this side. Okay. Eventually I have to square it and get 36 and add it with a negative 25. I don't think I'm communicating well. if you wanted to square this out and write 36 and 36, that's fine. Okay. But what's more important is that number, because that number helps you to factor it. And that's what you really wanted to do right there. You wanted to get all your x's inside that quantity squared. Anybody else?
So when you do this, it's always going to be x plus or minus the half of the number for whatever is in front of x.
Mm-hmm.
Okay.
And notice how when I said x times -12, I wrote -6 because that -6 and that -6 are the same thing. So if you said -6 here, you'll write x minus 6. Over here, when I had half times 6 was +3, maybe I should have put a positive here. Okay. That's why I wrote +3, because that +3 and that x plus 3 are the same thing. The problem's trying to give you hints. Okay, it's trying to help you work through this process. Okay. Anybody else? Okay, we will do more of these tomorrow night. We have a quiz tomorrow night, and we have more learning to do tomorrow night too. We got a lot. Quiz, bring, okay, a couple things. How many people are still here? Most of you, cool. The quiz is going to be open note. Hello. Okay, read the closed captioning. The quiz is going to be open note. So you can bring your notes to help you on tomorrow's quiz at the end of class. Okay? So I'll see you guys all tomorrow. Get some sleep. Take care. Bye-bye.
Got a question.
Yeah,
Since it's gonna be open notes, I mean, I take my notes on an iPad.
you're okay.
Oh, okay. Thank you.
I'll let you have that one. Yeah.
Okay.
Okay.
Thank you.
Professor, sorry to step away for a second. Are we doing anything for roll?
No, I talk too much, and I just don't want to bug people anymore. So I'll
Thank you,
take
Professor.
roll tomorrow night. Yeah. See you.
All right.
Bye-bye.
Thank you, Professor.
Bye-bye. See you. Hasta bye-bye.